For this warm-up, we're provided with a graph. The graph shows velocity over a period of time, which is 6 seconds. In this case, or 7 seconds, you could say. And the question is, how fast was an object going at 3 seconds, and how far did the object go between 1 and 6 seconds? Since this is a velocity versus time graph, so since it's a velocity graph, it means that any one of these points represents a velocity. So if they're asking for what's the velocity at 3, then it's simply 15, because the y value at x equals 3 is 15, which is why we have 15 feet per second. How far did the object go between 1 and 6 seconds? Now we're asking how far. It's a distance. And in the previous lesson, we learned that the area underneath this graph represents the total distance traveled. They say distance, I call it displacement. So, the question is between 1 and 6. And 1 and 6 would represent, I'm trying to make this look as nice as possible with the tools provided. It's kind of like this area right here. So all we have to really do is count the squares. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 for sure. So we definitely, 10. We have 10. Without a doubt, we got 10. But when it comes to the other ones, this and this kind of make it 11. And then that and that kind of make it 12. And then we got possibly 13 and 13 and a quarter. So 1.25. So when you add them all together, I get 13.25. This person got 12.6, really estimating. So 13.25. But you have to see what these things represent. Each box, this is 5 up, 1 to the right. Each box represents 5 feet, because 5 times 1, let me use a pen. 5 times 1 is 5. So you multiply this by 5, and then you get your answer. This person got this answer. I would have gotten a slightly higher answer depending on what this equals. Let's move on. Today you're going to be using the trapezoidal rule. This is how you find the area underneath the graph a little bit more accurately than just kind of estimating. Not necessarily accurately, but more consistent, meaning that I wouldn't have gotten a different answer than the previous person had we both used the trapezoid rule. So let's try that out. In this example, use the trapezoid rule to estimate the definite integral of this function from 1 to 7 using 3 increments. What they mean by 3 increments is to do the following. You find out how wide your area is. So pretty much you do 7 minus 1, and that will tell you the range, and then you divide by 3. And what happens when you do that, you make, this will give you 2, you create these equal 3 spaces that you're going to treat a certain way, and you're going to add them up. And as you can see, I just want to make sure I talk about this is the starting point, right? From 1 to 7. So from 1, you count 2 up, because 7 minus 1 divided by 3 equals 2. So 1 plus 2 is 3, boom. 3 plus 2 is 5, boom. 5 plus 2 is 7, boom. So you have these areas that you're going to find, 3 separate ones, and the way you get it is by looking at direction, 3 increments. Had they said 4, we would have divided by 4, and then we would have had 4 spaces. If they would have said 5, divided by 5, and so on. So what we do now is create trapezoids. We connect these points right here, making it a straight line, and this, if you recognize what this trapezoid is, that's a trapezoid right here. So what we can do is find the area of this space using the equation 1/2 times base 1 plus base 2 times height. I usually call it the average of the bases times the height will get it for you. So here's where you can kind of see it. They multiplied the 1/2, then they multiplied by the height, or in this case the width. I mean, the way you look at the trapezoid can be different. and then they add two bases together. So here's, I'm just going to indicate it again in the picture. This would be the height of the trapezoid, and these will be the two bases, and then they find the average by doing 1/2 of it and then multiplying by the height. So you find it for the individual parts. So for the first one, they ended up getting, well, they didn't actually calculate it, so I'm going to go ahead and do that. So we end up with 1/2 times 2. Let me get my highlighter real quick so I can show you what I did. What I first did was find what the y's are, obviously. So for f of 1, I plugged in 1 for x, got 5.6. And then for f of 3, I plugged in 3 for x, got 2.744. Then I plugged it in 1/2 times 2 times 5.6 plus 2.744 gave me 8.344. Add that to the second area, add that to the third area when you do it for all three areas, and then add them all together, and then you should get this value right here. So the trapezoid rule is a really good way to find areas, but as always, they're just an estimation of the area. But if you were to create more increments, if you use 10 increments, the area is going to be a lot more accurate. So do the same thing. Find out what your f values are for these things. Well, first of all, find out what the x's are. So in this case, what you want to do is you're going to go 7 minus 1 divided by 10. That would give you 6 divided by 10, which is 0.6. So the first one's going to be x being 1, and then 1.6, and then 2.2, 2.8, 3.4, and then so on. So you find all of your x's, which are right here. You find all of these x's until you get to 7. The last one should be 7. 7, and then you find all your y's. So you go f of 1, and then f of 1.6, and then so on. Then you can just find the individual ones by going 1/2 times the increment, which is 0.6, and then times base 1 and base 2, or let's not do that. You do a little bit of a shortcut. If you were to line them up all together, because you're going to add them up anyways, you'll see that the first term and the last term happen once, but any other term happens twice. So you can just add those together and then multiply by 0.6 one time and multiply by 1/2 one time. That will get you your answer a lot quicker. So this is a shortcut. This is going to make life a lot easier if you do this. Now, the previous method was fine because you only had 3 increments, but when you have like 10 increments, you want to use this method probably, unless you really enjoy having 10 lines and then adding them all together. Okay, that's it.